All right, let's take a look at an example about lockjaw. In this problem, we're going to have to draw a tree diagram, and we're going to draw it based on the problem we see here. An experimental blood test has been developed for lockjaw by the NIH. Due to the experimental nature of the test, it's not 100% accurate. In a trial of the blood test, the following probabilities were computed. 60% of the participants in the trial have lockjaw. Of the participants with lockjaw, 75% have had a positive blood test. And of the participants who do not have lockjaw, 80% have a negative blood test. So in order for me to answer the question down here, the first one said, what is the probability that a random participant will have a negative blood test? Part B, if a participant has a positive blood test, what is the probability that a random participant does not have lockjaw? I need to have a pretty nice looking tree diagram. So here's what our tree diagram is going to look like. We're going to look at people who have lockjaw, L, and people who do not have lockjaw, the complement of that. People could have lockjaw and get a positive blood test. People could have lockjaw and get a negative blood test. Remember, it's an experimental test. Of the ones who do not have lockjaw, they could have a positive test or they could have a negative test. So let's go ahead and label on the probabilities that were given to us. They said 60% of the participants in the trial have lockjaw. So on this branch up to L, I'm going to put 0.60. In other words, that's the probability of having lockjaw. Now, if the probability of having lockjaw is 60%, the probability that they don't have lockjaw is going to be 0.40. So this bottom part down here is the probability of not having lockjaw. Remember, these probabilities from each branch, they should always add up to 1. It said of the participants with lockjaw, 75% have had a positive blood test. So that means, given that they have lockjaw, the likelihood of a positive blood test, that's going to be 0.75. So this probability right here is the probability of a positive blood test given that they had lockjaw. If that probability is 0.75, the one on the other branch will be 0.25. In other words, the probability of a negative blood test, given that they have lockjaw, is 25%. All right, now let's look at the information on the problem again. Of the participants who do not have lockjaw, 80% have a negative blood test. So given that they do not have lockjaw, we're going down to negative, so we'll label this with 0.80. That means the other side is 0.20, because these have to add up to 1. So the probability that was given to me right there was the probability of a negative test given that they do not have lockjaw. So our entire tree is now labeled. So let's go back and think about what they're asking us. So it said we want what is the probability that a random participant will have a negative blood test. So I want to know the probability of a negative blood test. Now, they could have a negative blood test having lockjaw, so that's the branch that goes to L and then to negative. And remember, when we follow branches, we're essentially finding out the probability of lockjaw and a negative test. So that would be 0.60 times 0.25. We always multiply along the branches. However, remember, we can get to a negative test by not having lockjaw. So the complement of L and then to a negative test. And along that branch, it's 0.40 times 0.80. Separate branches add because there are two different ways to get to negative. And now we just need to work those out. So the first term here multiplies to 0.15. The second term multiplies to 0.32. Add those together, we get 0.47. So the likelihood of a negative test is going to be 47%. Now let's look at part B. For part B, it says, if a participant has a positive blood test, what is the probability that the random participant does not have lockjaw. So I want to know the probability that they do not have lockjaw given that they had a positive blood test. Now you might think, oh, this is on the branch that goes from not having lockjaw to positive. However, what's right here is given that they do not have lockjaw, what's the likelihood of a positive test? This is backwards from that. So the way we do this is we're going to utilize our definition for conditional probability. That definition says the bottom part here should be plus because we're only looking at the people with a positive test. And of those people, we want the ones who do not have lockjaw. So on top, we need the probability of not having lockjaw and having a positive test. We need to use the tree diagram that we've already constructed to get all of these pieces. So let's look at the top part. We need to find not having lockjaw and positive. That's the branch that goes from not having lockjaw to positive. So that's going to be 0.40 times 0.20. Now find the probability of a positive test. Well, that's like the probability of a negative test, but instead of finding all the branches that go to negative, we need to find all the branches that go to a positive test. So there's one along the top. That one would be 0.60 times 0.75. And then we're going to add to that the one that's on the bottom here of no lockjaw positive test. So that's 0.40 times 0.20. When I work out that top part, I get 0.08. When I work out the bottom part, I get 0.53. Going ahead and dividing those, I get approximately 0.151. So the likelihood of not having lockjaw, even though you got a positive test, is about 15.1%.